In this video, we're going to take a look at a process known as factoring. Today is the intro to factoring, where we factor through the distributive property. In general, when we talk about factoring, what we want to do is write an expression in terms of factors, which are expressions that multiply back to what we began with. To take an example of this, when we see a quantity that has a value multiplying with it, such as 2 times the quantity, let's say 3x minus 5. We are very used to distributing this value on the outside, in this case the 2, and saying that this is equal to 6x minus 10. And what we want to do today is we want to undo this multiplication. We want to go backwards to here. And that going backwards is factoring. And since going forward was multiplication, when we go backwards and we factor, we're going to use division to help us determine what this expression could be that multiplies to what we have. So in general, our results today are going to involve parentheses to show that multiplication. We have a couple types. I have a few examples on the front page here to where we are bringing out just a linear factor. So, as we see here, to factor each of the following by dividing out what we call the greatest common factor, and greatest meaning what is the most you can take away. Let's begin with example 1, a simple one where we see 2x plus 6. And when we want to break this down, we ask ourselves, what is it we can divide both terms by? In general, what you want to do is look at the smaller of your coefficients. So 2 is smaller than 6. And we ask ourselves, what can we divide this 2 by? And the factors of 2 are 1 as well as 2. And so we check. We know we can divide this by 2. Can we also divide 6 by a 2? And the answer to that is yes. And so we are dividing as much as we can because the most you can divide 2 by is itself. And we'll take that away from 6. Hence, we're bringing out the greatest factor. We also look at variables. We see the first term has an x worth the 2. The 6 has no x, so they do not have an x in common. Our last step then is, now that you've identified this 2 as a common factor, you go through division to see what would remain inside your quantity. 2x divided by 2, when we take 2 divided by 2, we get 1. We still have an x remaining, and so we end up with 1x. Remember, the 1 here in front of the x is understood, and so we don't need to write it down. After, we have 6 divided by 2, and positive 6 divided by 2 is a positive 3, so we put that here. And what we've done now is we've written a new expression that shows multiplication of two factors. 2 times the quantity x plus 3 when you distribute will give you 2x plus 6. And that is our goal today, to write as a product of expressions. So here's a case where we have a numerical value that we bring out. Over here, we have some more variables involved. So let's take a look at example 2. We see x squared y plus 5xy squared. Now the first thing to look at is reminding ourselves the coefficient at the beginning here is 1. We can see it and we can process a little bit easier sometimes when we do that. And we're going to ask ourselves, what do these have in common? When you get expressions that have variables involved, especially like this one, still start as you normally would and ask yourself, can I divide the coefficients by a number value? And the smaller of the two numbers is 1. We can divide that by 1. We can divide 5 by 1. But dividing by 1 will not have an effect. So since dividing by 1 is not going to do anything, it's not going to change any of our values like dividing by 2 did, let's look at the variables instead. Here we have x squared in our first term, and we have an x in our second term. And we do see that there is an x in common in these two expressions. So I'm going to consider bringing an x away. We also see that both terms have a y. So something they must have in common is a y as well. We want to pay attention to exponents too. When we see variables with exponents, we understand those. When we see variables without an exponent, we want to remember that the understood exponent is 1. So this first term is really 1x squared y to the first, and the second is 5x to the first y to the second. When we want to consider how many x's we can bring from these two terms, we check the smaller of the two exponents on that variable, because we cannot take more x's away than are present in the second term. So with x, we see an exponent of 2 and an exponent of 1. The most we can take away is x to the first, and so we'll take an x away from both terms. And the same with y's. We have y to the first in this first part here, y to the second in the last part. And again, we cannot take away more than the least amount. So 1 was the smallest exponent, so we'll take a single y away. So our common factor here is just involving the variables x and y. So we'll start our expression, xy times, and then what we do is we divide to see what's remaining inside this quantity. At the beginning, we have x to the second. Bringing an x away from that, we'll still have 1x remaining. We had y to the first. We took y to the first away, so y is no longer remaining after we take it out. Afterwards, we have a plus 5, and we had an x. We took an x away. There are no x's remaining. We had y to the second, so 2 y's present here. We're taking a single y away, and we still have a y. And again, now we have a product of factors, and we see that if we distribute xy into this set of parentheses here, we'll end up getting x squared y plus 5x y squared. And that is our goal, again, whether it's a number or a variable, to bring out a common factor to rewrite as multiplication. Let's look at a couple more here. In number 3, we have 12x squared plus 18x to the third. This is going to be an example where we involve both dividing by a number and by a variable. So let's start at the beginning here. Let's look at our numbers. We have 12 and 18 for our coefficients. 12 is smaller than 18, so we ask ourselves, what can we divide this smaller number by? We try to divide it by itself. We know we can take 12 divided by 12. We then ask, can 12 go into 18? And since that doesn't work, we'll work our way down here. The next largest number we can divide 12 by is 6. And we check over here, 18 is also divisible by 6. So 6 is going to be the largest factor we can divide by. And again, the goal is to divide by the most possible. We also see that there is an x in both terms, so we do know we can take an x away. And when we look at the exponents, we have an exponent of 2 and an exponent of 3. We can only take away the smaller amount from each term. So the smallest exponent with x is a 2. We'll divide by x squared. We can take both x's away from this first term, and we're also able to take away those 2 x's from the last term. Now that we've established the common factor, we have 6x squared times, and we take a look. Once we divide, we'll go through one at a time here. Divide your coefficient. 12 divided by 6 is 2. You had x to the second. You're dividing by x to the second. X is no longer remaining in this first term. Afterwards, we have 18 divided by 6. That's a positive 3. We do need a plus sign to show this positive. Every time you write a new part down, a new term down, you need a plus or a minus to link it to the first. We have the positive 3. We had x to the third. We're taking x to the second away. So we had 3 x's, taking 2 away. We still have a single x remaining. And that leaves us with this new expression, 6x squared times the quantity 2 plus 3x. And one more. These were all cases where we had 2 terms. We can do as many terms as we need to. In example 4, we see 3 terms. We have a trinomial over here, and we're going to divide it by as much as we can. So we set this one up. We have 4x, 12x squared, and 16x to the third. Go to your smallest coefficient of 4 ask yourself, can I divide by that number? Well, 4 divided by 4 will work. 12 divided by 4 also gives us an integer value, and 16 is also divisible by 4. We check the x's. They all have an x term. We can guaranteed bring at least x away. We check the exponents. We have x to the third, x to the second, x to the first. We always go off of the smallest exponent. So x to the first is the smallest that we'll bring away. Okay, so our common factor here is 4x. Now our job is to finish that division. Going back here, we have 4 divided by 4, which is 1, and x divided by x cancels. A common mistake here is to confuse division with subtraction, and sometimes we like to put a 0 in this spot. But we do need a 1 here for our distribution. We continue on and we see the 12 divided by 4. And 12 divided by 4 is 3, positive 3. And with a new term, we need a new symbol to link it to the first. X to the second divided by x to the first, we'll still have an x remaining. And then lastly, we move on to the 16. 16 divided by 4 is positive 4. And again, we'll link with that plus sign for the positive. We have x to the third, take an x away, and we are left with x to the second. And just like before, we have a new expression that will multiply to the expression that we began with. 4x, when you distribute into this set of parentheses, will give us the 3 terms that we began with. And again, this is why we need the 1 at the beginning, because 4x times 1 is how we get that 4x for our first spot. So these 4 cases are scenarios where we just bring out a common factor and we're finished. There are some other scenarios that we'll start practicing. Beginning today, we'll look at a case where we have 4 terms, and then we'll move on to cases where we just have 3. What else we can do? I have a couple of examples already worked for you. We have a strategy for when we have 4 terms. It's called factor by grouping. And when we factor by grouping, what we're doing is we take the 4 parts of a polynomial. So if we look at example 1 here, we have 25x cubed plus 5x squared plus 30x plus 6. And what we're going to do is we're going to reuse the same process we just did in the previous examples. But what we're going to do is look at 2 terms at a time. So these first 2 terms that we have highlighted in blue, we're going to look at those first and ask ourselves, what can we factor from them? In this first group, the 25x cubed and the 5x squared, we can divide them both by 5, and we can take an x squared away from each. And that is where I got this expression, 5x squared plus 5x plus 1. Times 5x plus 1, sorry. For the second set, it's a similar idea. We ask ourselves, what can we divide by? And with 30x and 6, we can divide them both by 6. All right, so let's take a look here with these examples, and I'm going to show you how this works with a blank template here. Looking at example 5, you might notice that, again, we have 4 terms involved. And so what we do is we group. You can draw a dashed line here to show the 2 halves. Okay, it's not anything other than a visual separator. And what we're going to do is walk through those steps and see what we can divide each half by. In the first case, let's look at 8 and 64. And again, look off the smaller number. The smaller coefficient is 8. Let's check. Can we divide both terms by that value? And we see that we can, so we'll keep it. And then we see that both terms have an x. So we'll divide by an x as well. And we look at the 2 exponents, and we will use the smaller of those 2. And so we'll use x to the second. So in this first group, we'll get to that second group in a second. In this first group, they have an x squared in common, 8x squared in common that we'll bring out. And then inside of these parentheses, we'll divide what we had before. 8 divided by 8 is 1, which we can put down if we need to. We have x to the third, take away x to the second, we still have an x remaining. And you might recall earlier, we said that the 1 is understood as a coefficient. It is not necessary to write it down. After that, we divide again. We have 64 divided by 8. That's positive 8. We had x to the second. We took x to the second away, so no x is remaining here. So once we bring out this common factor, we're left with x plus 8. Now we're going to repeat those steps, and then we're going to see something that happens. In this next set, we have x and 8, and if we need to, we can put a 1 in front of that x as a visual. And we see, what can we divide by? Well, let's plan ahead. The first term has an x, the last term does not. It's a constant term. So we can't divide by an x, so we have to divide by a number at least. And when we think of 1 and 8, we notice the only thing that we can divide these by is the number 1. And that is sometimes the case. This is one of those scenarios where we need to divide by the number 1. And we're going to divide by a positive 1 here, which I'm going to show below. And dividing by the positive 1 is important to us. As you'll see, when we start dividing here, 1x divided by 1 is x. And 8 divided by 1 is positive 8, which I'll show with that plus. And what was important to happen in this process is inside these two sets of parentheses, we get a common expression. Both halves, once we factor, have a factor of x plus 8. Our last step of factoring here is we bring out this common factor that we see in each half, this x plus 8. And if we bring that to the front, once we take x plus 8 away from this blue half at the beginning, the only thing that would be remaining is 8x squared. Once we take x plus 8 away from the second half in red, the only thing that would be remaining is this positive 1. And factor by grouping is going to work this way every time to where we end with two, what we call binomial factors, two sets of parentheses that have two parts each. And that is the key. Getting these matching parentheses is key each and every time. And actually, we can use that to help us determine what we need to divide by sometimes, as we'll see in the next example. For example 6, walking through again, we split it in half. We have 4 terms, so let's look at 2 halves at a time. In the first case, we have 6v to the third and 16v to the second. We ask ourselves, can I divide both of these by 6? At the beginning it works, but 16 and 6 do not divide evenly. So we'll try another value. Let's keep looking at the smaller number 6. The next largest number I can divide it by is 3. I cannot divide 16 by 3, so we try one more time. 6 is also divisible by 2. 16 is divisible by 2. And that's the largest number we can divide both by. We also see they both have a v, and the smallest exponent present in this half is 2, so we'll divide by v to the second. If we factor out 2v to the second, let's see what we have remaining. In the first case, 6 divided by 2 is 3. V to the third, take away 2 v's, we still have a v remaining. At the end, we have negative 16 divided by 2, that's negative 8. We had v to the second, we took v to the second away, no more v remaining. Now, what I'm thinking is we brought out a common factor here. We were left with 3v minus 8 in parentheses. We want to get that 3v minus 8 again when we repeat this process. So over on this half, we want 3v minus 8 to appear. And I mention that because sometimes it is not obvious to us what we can divide by. When we look at 21 and 56, it might not be apparent that we can divide them both by 7, for example. But I know 7 is the number I want, positive 7, because 21 divided by 7 gives me this first value of 3. And we still have the v remaining. And likewise, negative 56 divided by 7 gives us negative 8 to match the first half. So once you get a half completed, you can use that as a context clue to remind you of what it is you need to divide by. So I'm going to write the positive 7 here. And again, all we're doing is dividing by that 7. 21v divided by 7 is 3v. Negative 56 divided by 7 is negative 8. Since those two sets of parentheses match, all we need to do is bring that factor out, 3v minus 8. Once you do, the two matching parts, the two parts remaining, in blue, we still have 2v to the second, and in red, we have the positive 7. All right. So that was two cases where we had all positives. We had some minus signs involved in this next one. They generally are set up the same way each time, and so we get very similar results. Let's look at a case here where our second half starts with a negative. That's actually going to influence a decision for us, but it all still starts the same. Divide into two halves and look at each half at a time. 28 and 16, walk through and you'll find that they are both divisible by 4, and they both have y squared in common, the smaller of the two exponents. So if we divide 4y squared from each part, we'll be left with 7y plus 4. Here's what we need to happen in the next case. We know that we want to get a 7y plus 4. To do that, we have to divide by something that will allow us to create that expression. And here we see the negative 21y minus 12. We have negative numbers in these two cases, and we want to end with positive numbers. And what that's telling me right away is I need to divide by a negative value. A general rule that we can follow is if your group starts with a negative, then divide by negative. This is a strategy that will assist you in factoring correctly. But you can also use that numerical sense in that negative divided by another negative is a positive answer. Now, another clue is we want to get 7. So when we think about our multiplication facts, 21 divided by 3 is 7, and 12 divided by 3 is 4. And that is a quick way I can realize that I need to divide by a negative 3. Okay, once we do that, we check our two factors in parentheses are the same. And so our first case is 7y plus 4. And our second factor is what we brought out from the blue, so 4y squared, and the red, negative 3. And again, our results look similar each time. We get two binomial factors. All right, one last case then. If we have some extra variables involved, it's all the same process. Once you get it, you've got it, but sometimes we need a little practice before we get there. Here we have 12bc minus 4bd. Yes, there are a lot of letters, but still focus on those coefficients first. We see coefficients of 12 and 4. We realize we can divide them both by 4. We also see both terms have a b. They do not both have c. They do not both have d, so that is where we'll stop with that common factor. When you divide by 4b, you will be left with 12 divided by 4 is 3. You have b, take it away, no more b, but there is still a c. Here, negative 4 divided by 4 is negative 1. B divided by b cancels. We still have a d remaining. So we get minus 1d, but the 1 is not necessary. And then we realize we want to get the same thing over here. We want to get 3c minus d again. And here we are. We need to get a positive 3, but We're starting with a negative 15, and that is why we need to divide by that negative number. And whatever we divide by here, we divide again here. Looking at 15 and 5, we know we can divide them both by 5. So we'll divide by negative 5. We see they both have an x in common, and that is the only variable they both share. When you factor out 5x, you can check. Negative 15 divided by negative 5 is positive 3. Take an x away, and you still have a c remaining. 5 divided by negative 5 is negative 1, but remember that negative 1 is optional here. You have an x divided by x, which cancels, but there is still a d remaining. And then we are finally there. We have matching factors that will bring out to the front. And we have 3c minus d as one factor, and then what our common factor from each group will be the other. So we get 4b minus 5x. And this strategy is the one that we will be using more next time. It allows us to factor many cases where we have just 3 terms. So we want to get a good foundation today.